Second announcement, let's now talk about a super fast box. Before I do that, let me give you a quick short summary, short history of deep learning. Now, of course, this is one thread. There are so many threads, and so much work in deep learning was built, obviously, on the work of other giants before it. But there were a couple of very important events that I'm going to highlight today, not because they're the only two events, but in the context of my story, those two events are the primary threads. It all started, really, in 1995. While at Bell Labs, Jan LeCun observed that traditional computer recognition, computer perception, could be done better. Up until that point, the basic way people did it was hand-designed feature detectors. They would detect certain features, little edges, combinations of edges. They count the histogram of edges, the density of edges in a particular image. And from those edges, they would infer what object they were looking at. Most of that work was a patchwork of hand-engineered codes that had been built up and techniques that have been built up over years and years and years. As you know, computer vision has been around for 50, 60 years. Jan's observation was that instead of writing all of these hand-tuned codes, the world is so complicated, there aren't enough engineers to ever write all the code necessary to figure out how to understand the world, how to perceive the world. And he observed that, in fact, there's something else that's growing very quickly, that computation was growing quickly, that Moore's law was moving faster than the number of engineers in the world, certainly the number of computer vision engineers in the world. And so he came to the conclusion that maybe an approach that would be viable is to create a network, to design a network he called a convolution network that would be auto-trained. That it would start up with no software. It would start up unprogrammed, inspired a little bit by biology. Most of us were started with no programming. But it would start with a well-engineered neural network. He called it a convolution neural net. And if you had enough data, and more importantly, if you had enough computation, you could train this network and program it to observe and to recognize objects in the world. Well, that was his observation in 1995. He wrote a very, very good paper on that. I recommend everybody reading it. In 1998, he revealed with his colleagues a network that was built using that approach, and it makes sense that Jan would call it La Net, otherwise known in English as the net. The net was a deep convolution network. Layers and layers of convolution networks, and each layer would attempt to self-train, to learn through all the data you provided and the enormous amount of computation that you provided. It would learn what programming would detect features of images that it was presented with. The first layer might turn pixels and represent them as edges. The second layer might turn edges and discover what is known as textons, patches of textures. And the next layer after that may build up these things into higher level parts. Maybe the ears of a cat, the eyes of a dog. And then the last few layers, what is known as fully connected layers, would then assemble these pieces and translate an incoming image into a singular number at the output of this neural net. And that number would represent the encoding of the representation of that object. So the dog would have a representation in numbers, a cat would have a representation in number, a car would have a representation in number, and if we train this network to recognize 1,000 things, there would be 1,000 numbers in this vector. Well, that was his invention in 1998. La Net crushed the best handwriting recognition software up to that time. Utterly crushed it. LaNet is still in use by banks, by the post office, to recognize billions of pieces of handwritten checks and letters. And amazingly, it's able to recognize numbers and text no matter how bad you're writing. Well, I'm not sure that that's the case, but very bad writing. Somehow, it has learned from all of the data that has been presented, the ability to recognize numbers and handwriting recognition so reliably that it's now used, completely replacing humans. That was in 1998. Now, of course, a lot of research was done since then. A lot of research has been done without any public notice. These researchers dedicated to artificial intelligence, dedicated to machine learning, dedicated to deep learning, continue to advance the art. And all of a sudden, one day in the year 2012, Jeff Hinton's lab, University of Toronto, young man, Alex Krzyzewski, created a network that I referred to earlier called the Alexnet. The Alexnet entered into a competition, an international competition for large-scale visual recognition, the annual competition, the annual Olympics, if you will, of computer vision, entered into that competition with the Alexnet, created from Hinton's lab in University of Toronto, and it crushed, utterly crushed, the work of computer vision scientists over 50 years in one day. Whereas computer vision was making slow progress and incremental progress, and features and more code and tuning of code, one day, Alex Krzyzewski introduces the Alexnet that he trained on GPUs, and it was the only submission based on GPUs that year. And it crushed everything that was there before it. 84% accuracy, 16% error. That day was a very important day. On that year, he was the only person, Krzyzewski was the only person that submitted work that was trained on a GPU. The next year after that, 50% of the work was trained on NVIDIA GPUs. The year after that, almost every single submission was based on GPU-accelerated training. Something happened, and it was very, very big. And in fact, it didn't stop. So it turns out that the event, I think, just happened in September and had an error rate of about 7%. Literally days later, Baidu, Andrew Ng's lab, announced that they had broken that record at 5.98% of error, or 94% accuracy. And then days after that, Microsoft announced that they were able to, for the very first time in the history of computer vision, beat a human in recognition. Now this contest is this human, let me tell you about this human. This contest is quite amazing. You have to be trained on 1.5 million images. I mean, first of all, I can't even imagine 1.5 million images. You train on 1.5 million images, and you have to train your neural net, this deep network of yours, to recognize 1,000 things. 1,000 things. Now, it's 1,000 things and many species of dogs and fruit and things like that. I'm not sure I know 1,000 things. But anyways, this network is trained on 1.5 million images, on 1,000 things, and then it has to be compared, of course, to each other. But for the very first time, because of the sacrifice of one young man, Andrej Karpathy, he's sitting right there. Maybe, Andrej, just stand up for a second. Let's just pop your head up. Ladies and gentlemen, Andrej Karpathy. One of the great researchers in this field, and a researcher from Stanford, and I'm going to have him talk in just a moment, but he is the reference human. I have to say that not only did he go through extensive training on that database, he is the reference human, which basically says any one of these results would have beaten the rest of us. Okay? This is an amazing achievement. Microsoft, for the very first time in history, a computer was able to recognize images better than a superhuman. And then shortly after that, literally days after that, Google announced that they beat that result. The race is on. The race is on.